Hello everyone, I am Balaji Rao. Welcome to BR Max class. We are doing first class of linear inequalities objective part. This objective part is mainly considering JEE main students, MCET students, KCET students, Maharashtra CET students. This linear inequalities chapter is important or not important? Actually, this chapter is very important because while doing a relations and functions chapter or calculus part, so many times we will get a situation that to find the x values which satisfy given inequalities. So whatever you learn in this chapter, we'll use not only in this chapter, while doing other chapters also. Whatever you learn in this chapter, those concepts are definitely going to be helpful. What we are going to learn in today's class. See, even though if you didn't learn linear inequalities through NCERT textbook, from this video onwards, if you follow, then you can understand this full chapter. This video is created in that procedure only. In today's class is all about basics. See, in today's class, we will learn about intervals. What is closed interval a comma b? What is open interval a comma b? What is closed a open b? What is interval open a closed b? All those things we will learn. And in this linear inequalities, few rules are there which are important. We will learn rules of those inequalities and we will learn how to use those rules while solving the problems. And to understand these rules, in this class, we will do around 10 problems to understand those rules properly. This video is all about basic things. It is like zero to hero. Those who do not know anything about linear inequalities, they also can understand. This video is created in that way. Okay. So in next class, we will do the problems based on wavy curve method. How we use wavy curve method, which is very useful. In next class, we will take few examples and we will solve those problems with the help of wavy curve method. Then you will come to know how easy it is to solve an inequality with the help of wavy curve method. See, this video is completely free. In case if you want to support your teacher, I have my own Android app, BR Max Class. You can find this chapter along with handwritten notes. You please download that app, BR Max Class. You come over there. Linear inequalities chapter is there. A nominal price is kept for this linear inequalities. What you will get for paying that nominal price? You will get my video lectures on linear inequalities chapter class 11 NCERT test. Along with that NCERT textbook, this objective, complete objective part also you will get. So for paying that nominal price, you will get NCERT video solutions and you will get objective part of linear inequalities also. Please do check our Android app. Before going to start this video, just drop a like for this video, share this video with your friends. In case if you are not yet subscribed to my channel, subscribe now. In intervals, total 4 types of intervals are there. We'll see one after another what are those intervals. You observe this. This is first interval. How you read this interval? We read this interval as closed interval a comma b. Whenever you see this type of brackets, you see these brackets are known as closed brackets. So how you read this interval? We read it as closed interval a comma b. Somewhere you saw like this, closed interval 1 comma 2. You read it as closed interval 1 comma 2. Okay. What it mean? Closed interval a comma b means what? Look here. Closed interval a comma b contains all real numbers between a and b. Closed interval a comma b contains all real numbers between a and b, including both a and b. This I'll try to explain on the number line. We'll take one example to understand this. I'll take example the closed interval 1 comma 3. How you read this? We read it as closed interval 1 comma 3. Closed interval 1 comma 3 means what? It contains all real numbers in between 1 and 3, including both 1 and 3. I'll mark this closed interval on this number line. See here, first 1 is there. You write a dark circle. That means here this is closed interval. No? Closed interval means 1 is also included, 3 is also included. That's why I'm marking a dark circle here. Okay. Here one dark circle. At 3 also you mark one dark circle. Okay. At 3 also you mark one dark circle. Why this dark circle here? Because this is closed bracket. This is closed bracket. Okay. Now you mark all the things in between these two. Right. See here. This, you see this blue color part is there. Na? What is this? This is the closed interval 1 comma 3. Whatever numbers present in this, that are present in this interval. This interval is closed interval 1 comma 3. For example, in this interval 1.9 is there. You see here in this part 1.9 is there. 1.9 is there. Yes, 1.9 will be present somewhere here. Yes, 1.9 is present. So that means 1.9 is in this interval. For example, 0.5. 0.5 is not on this part. Not on this part. 0.5 does not belongs to this interval. I hope you are understanding. Closed interval 1 comma 3 means what? Closed interval 1 comma 3 contains all real numbers between 1 and 3, including both 1 and 3. Now, a small question to you. See, this is closed interval 1 comma 3. In this interval, 1 is there? Yes. That's why here this dark circle is there. In this interval, 1 is there. In this interval, 1.00001 is there in this interval? Yes. All real numbers in between 1 and 3, including both 1 and 3, are present in this interval. See, in this interval, 2.999999. This number is present in this interval. Yes, 2.999 somewhere here. This number present in this interval. 3. 3 is present in this interval. Yes, because this is closed interval. Na? In closed interval, 1 is also included, 3 is also included. 3 is belongs to this interval. 3 is present in this interval. I hope you are understanding. Closed interval 1 comma 3 contains all the real numbers between 1 and 3, including both 1 and 3. For example, another example I'll take. The closed interval, how to read this, that also you need to understand. The closed interval 1 by 2 comma 4. Something is like this. What this interval contains, closed interval 1 by 2 comma 4. You mark this on the number line. See here 1 by 2. 1 by 2 means what? 0.5. Where is 0.5? Here 0.5 will be there. So here this is closed interval. Na? At 0.5 you draw the dark circle because it is closed interval. This is 1 by 2. 2, 4. 4 is here, right? You mark one dark circle here 4. We are writing dark circle means that point is included. Now join. See, whatever numbers are present in this part, in this blue color part, all the numbers present in this interval. I hope you are understanding. In this interval, 0.4 is there? No. This interval starts from 0.5, 0.4 somewhere here. In this interval, 0.4 does not belongs to this interval, right? In this interval, 3 is there? Yes, 3 is present. In this interval, 4.001 is present in this interval? No, right? So this is closed interval 1 by 2 comma 4. What it contains? It contains all the real numbers between 1 by 2 to 4 on the number line, right? Now I want you to mark this on the number line minus 2 comma 3. You please mark this part on the number line. Okay, if you mark it, how it comes? This is closed interval. Na? Means minus 2 is also included, 3 is also included. See, you join them. See, this part, this red color part is there. Na? This part is what? This part is the closed interval minus 2 comma 3. So you are learning about intervals. In the intervals, first one is the closed interval a comma b. How you read it as? You read it as closed interval a comma b. Now we'll move to second one. You observe the second one. Second one is this. What is this? This is open interval a comma b. You see this here, you observe the brackets. See, these are like this. Whenever brackets are like this, we call it as closed interval a comma b. Whenever brackets are like this, we call it as open interval a comma b. I hope you are understanding the difference. This is closed interval a comma b. This is open interval a comma b. Okay. See here, this is open interval a comma b. How we read it as means? We read it as open interval a comma b. You observe here, what is this interval? How we read it as? We read it as open interval a comma b. This is open interval a comma b. Open interval a comma b contains all real numbers between a and b, excluding both a and b. So what is the difference of closed interval a comma b and open interval a comma b? Closed interval a comma b also contains all real numbers between a and b. You see here, closed interval a comma b. See this closed interval a comma b contains all real numbers between a and b, including both a and b. Right here, this is open interval a comma b. This is also contains all real numbers between a and b. In open interval, we'll exclude both a and b. In a closed interval, we'll include both a and b. That is the difference, right? So, okay. Open interval a comma b contains all real numbers between a and b, excluding both a and b. We'll try to understand this. Here, I'll mark the interval. How we read it as? How we read it as? We read it as open interval minus 1 comma 2. What it contains? Open interval minus 1 comma 2 contains all real numbers between minus 1 and 2, excluding both minus 1 and 2. Here, minus 1 is not in this interval. Minus 1 is not in this interval. So, how we will mark this on the number line? As minus 1 is not in this interval, at minus 1, you draw open circle. It indicates minus 1 is not included. Okay. So, here you observe, I am drawing like this. Earlier, we drawn it as a dark circle. In this interval, 2 is present? No. We are excluding both 1 and minus 1 and 2. Okay. So at 2 also, you draw one open circle. Okay. Now, see, this part is there, this blue color part. You observe here, all the real numbers in between minus 2, minus 1 and 2. These both minus 1, 2 are not included. Not included. Okay. So now my question is, in this interval, minus 0.5 is there? Minus 0.5. You see here, minus 0 point somewhere will be here on the number line. Minus 0.5. Yes, minus 0.5 belongs to this interval. In this interval, minus 0.99999 is there in this interval? Yes, minus 0.999 will come somewhere here, right? So that is in this interval. Now, in this interval, minus 1 is present. In this interval, minus 1 is present. No, both these two numbers are excluded. Minus 1 is excluded, 2 is also excluded. So, minus 1, see here, minus 1 does not belongs to this interval, open interval, minus 1 comma 2. This symbol is belong symbol. See, minus 1 does not belongs to this interval. Is 2 is belongs to this interval? 2 is present in this interval? No, 2 is also does not belongs to this interval. Then what are present in this interval? All the real numbers between minus 1 and 2, excluding both minus 1 and 2. I hope you understand. First one is what? First one is the closed interval a comma b. Second one is what? Second one is open interval a comma b. Now we'll learn about this third one. What is this third one? See this third one. Observe this third one. What is this? You see here bracket is what? Closed bracket is there. Here open bracket is there. How we read this interval? How we read this interval? Look here. The interval closed A. This side closed bracket is then the interval closed A open V. How you read this interval? The interval closed A open V. We read it as the interval closed A open V. what it mean, what it contains. You observe? What is this? How you read it as? The interval closed A, open B contains all real numbers between A and B. The interval closed A, open B contains all real numbers between A and B. You see, this dialogue is common in all these intervals. Contains all real numbers between A and B. Here, closed interval is there. Na? That's why between A and B, including A, we are including A. A is present in this interval, but excluding B. Right? Whenever closed bracket is there, that particular number is included. Whenever open bracket is there, that particular number is excluded. So how you read it as? You read it as the interval closed A, open B. It contains all real numbers between A and B. It contains all real numbers between A and B, including A, excluding B. We will try to understand this on the number line. Okay. You observe this. How you read it as? The interval closed 0, open 3. Right? What it contains? Interval closed 0, open 3 contains all real numbers between 0 and 3. 0 is included, 3 is excluded. Okay. So how you mark this on the number line? See, 0 is included. Na? At 0, you draw the dark circle that indicates that 0 is included. See, 3 is not included because this is open 3. So at 3, you draw one open circle like this. It indicates that this point is not a part of the solution. Okay. Now you join, you observe this part is there, na? Blue color part. That part is, what is this part? The interval closed 0, open 3. The interval closed 0, open 3 contains all the real numbers between 0 and 3. 0 is included, 3 is excluded. In this interval, closed 0, open 3, 0 is present? Yes. You observe the interval, closed 0, open 3. In this interval, 0 is present? Yes, 0 is present. In this interval, 3 is present? No. In this interval, 3 is not present. In this interval, 0.99 is present? Yes, 0.99 somewhere present here. Yes, 0.99 is present here. In this interval, 2.999 is present in this interval? Yes, 2.999 is present in this interval. In this interval, 3.01 is present? No. This doesn't contains the number. This interval does not contains the number 3.01. I hope you are understanding. Now, see this fourth one. What is this fourth one? How you read it as? Now you are able to read this. How you read it as? The interval, see a bracket here, the interval open A comma closed B. How you read it as? The interval open A closed B. This is the interval open A closed B. You see here how you read it? The interval open A closed B contains all the real numbers between A and B, excluding A and including B. See, excluding A. You can observe here at A, open bracket is there. See here, excluding A. Whenever open bracket is there, that is excluding A. Here, including B. I'll explain this on the number line. You see this interval, how you read it as? Interval open -2, closed 1. You need to mark this on the number line. See here, open -2. Open -2 means -2 is not included. So you just draw one open circle like this. 1 is included. This is closed 1. 1 is included. At 1, you just mark one dark circle. Now, what numbers present in this interval means all the real numbers. All the real numbers in between -2 and 1 are present in this interval. -2 is excluded. 1 is included. So, I hope you understand all these four types of intervals, right? So, what is the first interval? By seeing this interval, you need to know first how we read this. We read it as closed interval A comma B. How we read it as? We read it as open interval A comma B. How we read it as? We read it as the interval closed A, open B. How we read it as? We read it as the interval open A, closed B. You observe here, if you see this type of notation, x belongs to closed interval 1 comma 3, then this can be written like this. Here, this is closed interval 1 comma 3. Na? So, then this can be written as 1 less than or equal to x less than or equal to 3. So, when x belongs to this interval, it means that x values lies in this interval including both 1 and 3. This can be written like this. It indicates that x value lies in between 1 and 3. Here, less than or equal to indicates that 1 is included. Here also, equality symbol indicates that this 3 is included. So, x belongs to closed interval 1 comma 3 means this can be written as 1 less than or equal to x less than or equal to 3. Similarly, you see here, if you saw this notation, x belongs to open interval minus 1 comma 2. How we write this? We write like this. Here it is open interval. In this, minus 1 is not included. So we write it as minus 1 strictly less than x strictly less than 2. If x belongs to this interval, then we'll write like this. This indicates that x lies in between minus 1 and 2. Minus 1 is not included, 2 is also not included. Similarly, when you see this type of notation, x belongs to closed 0, open 3. How we write this in interval form? How we write this? We write like this. Here, closed 0 is there. That means 0 is included. When 0 is included, we will write less than or equal to. When closed bracket is there, this equality symbol will come. X less than. You see, this is not closed bracket. Here 3 is not included in this interval. So we write like this. So whenever you see such type of things, we'll write like this. 0 less than or equal to x strictly less than 3. Okay. Similarly, you see here x belongs to open interval minus 2, closed 1. How we write this in symbolic form? You answer. How we'll write this? Which side is less than symbol? Which side is less than or equal to? Here, open bracket is there here. So what we'll write? Minus 2 is strictly less than x less than or equal to 1. I hope you are understand. So whenever x is in this interval, then we can write like this. So you learn all four types of intervals. Now we'll come to the difference between equation and inequality. What is the difference between equation and inequalities? First, what is equation? What is equation? Between two numbers or two algebraic quantities, if we use the symbol equal, then that will form an equation. For example, two algebraic quantities I'll take. See 2x and 5. Two quantities I taken. If I use the symbol to relate them, if I use the symbol equal to relate them, then what this forms? 2x equal to 5 is an equation. So, generally what happens in equation, two quantities will be there. One is left hand side, another one is right hand side. If these two are related with the symbol equal, then what this forms? This forms an equation. For example, x square plus 2x plus 5 equal to 3x. Actually, here two quantities are there. See, left hand side part x square plus 2x plus 5, right hand side part 3x is there. To relate these two things, I used the symbol equal. So, what is this? This is an equation. Further, we can simplify this. Okay, between two real numbers or two algebraic equations, if we use the symbol equal, then it forms a equation. I hope you understand. Then what is inequality? You observe here. What is inequality? Inequality definition is like this. See, inequality definition is two real numbers or two algebraic expressions related by the symbols. You see, this symbol is, we call it as less than. Moreover, we call it as strictly less than. This is strictly less than. Okay, this symbol we call it as less than or equal to. See here, equal line type is there. The symbol we call it as less than or equal to. This symbol is greater than. This is greater than symbol. The symbol is greater than or equal to. Forms an inequality. Two real numbers or two algebraic expressions are related with these symbols forms an inequality. For example, 2x plus 3 is one algebraic quantity. 5 is another algebraic quantity. If we use an inequality symbol, we know that any one of these symbol, inequality symbol, I written greater than here. What is this? This is an inequality. This is one inequality. Okay. Now, I'll take one more. X square plus 5 is less than or equal to minus 2. Actually, what is this? Left hand side part, one algebraic expression is there. Right hand side part, one algebraic expression is there. These two are related with this symbol, right? One of these symbols, if we use, what is this? This is inequality. What is this? This is an inequality, right? This is one inequality. This is one inequality. So you learn what is equation, what is inequality, what are inequalities. Okay. See, solving equation, solving inequalities, so much difference is there. See, solving an equation, see, till now you've done so many equations and you find out its x values or y values, whatever it is, depends upon the equation. Solving an equation, you see here, this is one equation, 2x plus 1 equal to 3. If I solve this equation, what x values I'll get? See here, 2x equal to 3 minus 1 is 2. You can simplify this. X equal to 2 divided by 2. So x equal to 1. So I solved this equation. I got its solution as x equal to 1. Okay. This is solving an equation. How you identified it is an equation? Because between two algebraic expressions, there is a symbol equal, right? So this is the procedure of solving equation. How we solve inequalities? You see here, same here one algebraic expression is there. Here one algebraic expression is there. Between these two, inequality symbol is there. You know what are inequality symbols? What are inequality symbols? Look here, the symbols are there. Na? These symbols are called inequality symbols. Less than or equal to, greater than or equal to, are called inequality symbols. Okay. Now, how to solve this? Actually, without knowing few rules, you cannot solve it. Just to explain the difference between equation and inequalities, I'll solve this. But without knowing rules of inequalities, you cannot do this. Just to explain the difference between solving equation and solving inequation, I am doing this. Right after this problem, after this, in next slide, we are going to learn what are those rules to solve an inequality. Okay. Here you see 2x plus 1 greater than 3. This is an inequality because of this symbol. Okay. Now 2x is greater than 3 minus 1. Okay. 2x is greater than 3 minus 1 is 2. Here I am dividing with 2. Actually, you cannot do like that. I am saying that just to explain the differences between these two, I am doing my own. You see, to subtract, there is a condition. To divide, there is a condition. All those things we are going to learn in the next slide. Okay, just wait. This can be written as x greater than 1. Okay, so x greater than 1. X greater than 1 means what? Here we suppose that x is a real number. We suppose that x is a real number. 2x plus 1 is greater than 3 and x is a real number. So when I solve this inequality, I got like this. When I solve this equation, I got like this. If I solve an equation, I got only one solution. 1 x equal to 1 is the solution of this equation. But here, for this inequality, how many solutions are there? You can see infinitely many solutions are there. Okay, you see, I'll try to explain this on the number line. X greater than 1. X greater than 1 means here strictly greater than is there. See here, strictly greater than is there. When strictly greater than is there, 1 is not included. Okay, 1 is not included. Greater than 1 means right hand side part of 1. All these numbers are greater than 1. 1.5 is greater than 1. 2.5 is greater than 1. All these, whatever number you take here, so anywhere you take here, all those numbers are greater than 1, right? Here for this so many solutions are there. How you write this in interval form? Just now you learn about intervals. Na? How you write this in interval form? We'll write like this. X belongs to open interval because this is strictly greater than 1 is not included. Open interval 1 to infinity. In this, you see so many numbers are there. Infinitely many numbers are there. This is solution of this inequality. For this inequality, number of solutions are infinite. 1.1, 1.2, 1.3, 2.1, 2.3, 2.01, 2.9999. All are solutions of this inequality. But for this equation, only one solution is there. X equal to 1 is the only one solution. Okay. So now we are going to learn how to solve an inequality. See, you know how to solve an equation. Until now, you learn how to solve equations, right? Now, how to solve an inequality? To solve an inequality, we need to know mainly four rules. Mainly four rules are there. Rule number one, you see, what is rule number one? Rule number one, for an inequality, if we add or subtract same real number on both sides, then sign of inequality remains same. You consider one inequality. Okay, for that, we'll add. I'll take only add. This we'll discuss later. I'll add same real number on both sides, then sign of inequality remains same. You observe here 10 greater than 2 is there here, right? 10 is greater than 2. Is it true? Yes, this is true. 10 is clearly greater than 5. 10 is clearly greater than 5. Yes, this is true. Okay. Now, for this inequality, I'll add I'll add same real number on both sides. Then sign of inequality remains same or changes, we will see. You select one number, that number will add on both sides. For example, I'll take 2. Add 2 or else add 6. Add 6 to this inequality on both sides. 10 plus 6 is greater than 5 plus 6. Okay, 10 plus 6 is 16. 16 is greater than 5 plus 6 is 11. You observe 16 is greater than 11. Is it is true or not? Is 16 is greater than 11? Yes, 16 is greater than 11. See, I taken one true inequality. You need to take an inequality which here between two real numbers I am saying. For an inequality, if you add same real number, you observe here, if you add same real number on both sides, inequality sign remains same. That means here greater than is there, na? That greater than remains greater than only. For an inequality, if we add same real number on both sides, then sign of inequality remains same. You see, this works for subtraction also. Here, I taken this example. 3 is less than 10. Is it true? Yes, 3 is less than 10. For this inequality, you subtract same real number on both sides. Sign of inequality remains same or changes, you check. Here 3 is less than 10. I'll take one number, 3, 5. I'll subtract 5. 10 minus 5. For this inequality, I am subtracting 5, right? 3 minus 5 is what? 3 minus 5 is minus 2. 10 minus 5 is what? 10 minus 5 is 5. What symbol is suitable here? Less than symbol is suitable or greater than symbol is suitable? Minus 2 is less than 5 is correct or minus 2 greater than 5 is correct? Clearly, this minus 2 is less than 5. That means what happened? This inequality sign changed or remains same? It remains same, right? So it is important. You need to know this property. What is this property? For an inequality, if you add same real number on both sides, then sign of inequality remains same. You can say like this also. For an inequality, if we subtract same real number on both sides, then sign of inequality remains same. You see here, this is one inequality here. For this inequality, if I add or subtract same real number on both sides, sign of inequality remains same. This is the first rule. Whenever we solve inequalities, you need to consider this. If this is, see here, this is you see, this is a one unknown value is there in this. In this, one unknown value is there, x. So if while solving this, solving this is nothing but finding x values. Solving is nothing but for what x values this inequality holds good, right? Okay, for what x values this inequality holds good. How to solve this inequality? See, I want x. For that, what I'll do, I'll subtract 5 on both sides. Here, x plus 5 is greater than 2. I'll subtract 5 on both sides. Yes, subtract 5 on both sides. What you will get? X plus 5 minus 5. So I'm subtracting 5 on both sides. What you know? For an inequality, if you subtract same real number on both sides, sign of inequality remains same, right? So this is greater than 2 minus 5. Okay, here plus 5 minus 5 will get cancelled. What you will get? X is greater than 2 minus 5 is minus 3. Actually, whenever we add, subtract, you can simplify this same like an equation procedure, but when we multiply with positive real number, negative real number, things will change. That we'll discuss in rule number 2. So what you got here, if x plus 5 is greater than 2, x is greater than minus 3. Okay, so this is solution of this inequality. If you want to write this in interval form, how you will write? We'll write like this: x belongs to open interval minus 3 to infinity. Okay, right. Now, what you learn? Rule number 1 you learn. What is rule number 1? For an inequality, if we add or subtract same real number on both sides, sign of inequality remains same. Okay. Second inequality, you observe, for an inequality, if we multiply or divide with same positive real number on both sides, then sign of inequality remains same. See, this is also sign of inequality remains same. Here what we are doing, if we multiply or divide with same positive real number. For an inequality, if we add or if we subtract or if we multiply or divide with same positive real number on both sides, sign of inequality remains same. I hope you are understanding. See, this is one inequality. For this inequality, you can add any real number. You can add any real number on both sides. Rule number 1 I am saying, you can add any real number on both sides, then sign of inequality remains same. For this inequality, if we subtract any real number on both sides, then also sign of inequality remains same. That is rule number 1. What is rule number 2? For an inequality, if we multiply with if I multiply with the same positive real number, same positive, here this is important, same positive real number, then sign of inequality remains same. If I multiply with negative real number, sign of inequality changes. That we will discuss in next point. Okay, so this is 2 less than 5. You take one positive quantity, take one positive one, take 3, multiply with the same positive real number on both sides. 2 into 3 is less than 5 into 3. 2 into 3 is what? 6. 5 into 3 is what? 15. 6 is less than 15, right? 6 is less than 15. Is it true? Yes, this is true inequality. After multiplying with same positive real number on both sides, then sign of inequality remains same. See, this is one inequality. If I multiply or divide with the same positive real number, then sign of inequality remains same. For example, I'll divide with 2. Okay, 2 is a positive number. I divide with 2. 5 divided by 2, 3 divided by 2. What is 5 divided by 2? 5 divided by 2 means half of 5. Half of 5 is 2.5, right? 3 divided by 2 is half of 3. Half of 3 is 1.5. See here, 2.5 is greater than 1.5 or less than 1.5? 2.5 is clearly greater than 1.5. That means for an inequality, if I divide with a positive real number, inequality sign remains same. So what is suitable symbol here? Greater than, because 5 by 2 is 2.5. 3 by 2 is 1.5. 2.5 clearly greater than 1.5. So what you are understanding, there is an inequality. For that inequality, if I multiply with the same positive real number on both sides, or if I divide with the same positive real number, if I divide with the same positive real number on both sides, sign of inequality remains same. For example, here 2x less than or equal to 4 is there. I'll divide this on both sides with the 2. Not only 2, any positive real number. 2x divided by 2, 4 divided by 2. See, this is an inequality. Actually, this is an equation. In this, unknown value is there. X is the variable. We need to find x. So, as I divided with 2 on both sides, what is this rule says? There, if there is an inequality, if you multiply or divide with same positive real number on both sides, sign of inequality remains same. So, what we'll write here? Less than or equal to we'll write, or greater than or equal to we'll write. As 2 is a positive real number, as we divided with positive real number, the sign of inequality remains same. That means 2, this is less than or equal to. So if I simplify this further, what I'll get? I'll get that x less than or equal to 4 by 2 is 2. So what is this? This is solution of this inequality, right? So how you will write this in interval form? number line, you observe the number line. On the number line, if you mark the 2, left hand side part, whatever the numbers are there, they are all less than 2. Here less than or equal to given, that means 2 is included. You can observe that this highlighted part is there, that highlighted part is the solution, right? So how you write it as from minus infinity to 2. You can observe here less than or equal to is there. That means this 2 is included. When 2 is included, at that time we will write closed interval, right? We will write closed interval minus infinity to 2, right? I hope you are understanding. Now see rule number 3. In this inequalities, what is rule number 3? For an inequality, if we multiply or divide with same negative real number, this is important. If I divide with same negative real number on both sides, sign of inequality changes. Sign of inequality changes. Look here, sign of inequality changes. This is important. Till now, whatever rule 1, rule 2 are there, you see, remain same. Rule 1, you see, sign of inequality remains same when we add or subtract same real number on both sides. Rule number 2, see, when you multiply divide with same positive real number, sign of inequality remains same. Rule number 3 is what? When we multiply or divide with same negative real number, sign of inequality changes. First time you are seeing this, sign of inequality changes. You see here, minus 3 is less than 5. Is it true? Yes, clearly minus 3 is smaller than 5. Minus 3 is less than 5. What I'll do, I'll multiply with the same negative real number on both sides. You take one negative real number, multiply on both sides. Negative real number, I'll take minus 2. Minus 3 into minus 2. I'm multiplying. Okay. 5 into minus 2. Okay, what happened? This is the inequality. For this inequality, I am multiplying with same negative real number on both sides. As per this property, they are saying inequality sign changes. That means less than is there, no? Less than changes to greater than. Let's see what will happen. Minus 3 into minus 2 is what? Minus 3 into minus 2 is 6. Okay. 5 into minus 2. 5 into minus 2 is what? Minus 10. You tell the relation between the 6 and minus 10. Is 6 is greater than minus 10 or 6 is less than minus 10? All positive numbers are greater than negative numbers clearly. So what is this? 6 is greater than minus 10 is correct. I hope you are understanding. So what is the point here? For an inequality, if we multiply with same negative real number on both sides, sign of inequality changes. This is important. For an inequality, if we multiply with negative real number, sign of inequality changes. So here less than is there, as we are multiplying with minus 2, this inequality changes to less than. I hope you are understanding. Similarly, you see here 5 is greater than 3. Is 5 is greater than 3? Yes, this inequality is true. For this inequality, if I divide with same negative real number on both sides, if I divide with same negative real number on both sides, okay, 5 divided by minus 2, 3 divided by minus 2. What is 5 divided by minus 2? 5 divided by minus 2 is minus 2.5. 3 divided by minus 2 is what? 3 divided by minus 2 is minus 1.5. Which one is bigger? Which one is smaller? I'll explain this on the number line. You observe this number line. Where is this minus 1.5? Somewhere here. This is minus 1.5. I'll mark this here. This number is minus 1.5. Where is minus 2.5? Minus 2.5 is here. See, minus 2.5. Please observe. This number is clearly smaller than this number. See, for my, you see this minus 1.5 is there, no? This side whatever numbers are there, they are all less than this minus 1.5, left hand side part. Minus 2.5 is left side of this number, so minus 2.5 clearly less than. So here this is clearly less than, but actual inequality sign is greater than. As we divided with the same negative real number on both sides, sign of inequality changes. This greater than is changes to less than. So what happened here? What to write? As 5 is greater than 3 is a true inequality. As I am dividing with the same negative real number on both sides, sign of inequality changes. This greater than changes to less than. I hope you are understanding, right? So this third rule is very, very important. You just do little bit of practice. Okay. I'll give some examples also. You practice those inequalities, then you will get clear clarity about these rules. Okay. Now you see, This is important. Do not cross multiply in inequalities. Do not cross multiply in inequalities. Many students will do this mistake, like suppose 2 by x equal to 3 is there. What is x means? What they'll do, they'll cross multiply, they'll say the answer is x equal to 2 by 3. But in inequalities you cannot do like that. You cannot write 2 by 3 greater than x. Is wrong. This is wrong. You cannot declare like this, right? We cannot cross multiply. What we can do, if you want to solve this, we can multiply. See, I'll multiply with x into 2 divided by x, 3 into x. If I write like this, left hand side part, you observe x will get cancelled. Now the point is, as we are multiplying with some number, inequality sign changes or remain same. For that, you need to know x is positive or negative. If x is positive, inequality sign remains same. I hope you are understanding. Rule number 2. For an inequality, if I multiply with a positive real number, inequality sign remains same. In case if x is negative, when I multiply with x on both sides to the inequality, in that case inequality sign changes, this greater than changes to less than. So here the problem is, we cannot solve this inequality until we don't know what is x. What is x means? X is positive or negative, you must know. Simply, if you solve this as 2 divided by 3 greater than x, 2 divided by 3 greater than x means x is less than 2 by 3. If you write like this, it is wrong. I hope you are understanding what I am trying to say. Here you see, 2 by 3 greater than x means x is less than 2 by 3. I written reverse order. For example, 2 is less than 3 is there. 2 is less than 3. That means 2 is smaller than 3. When I write this in reverse order, like 3 is obviously greater than 2. I hope you are understanding. This can be understood easily. Suppose 5 is greater than 2. When I write the reverse order, this inequality changes. 2 is less than 5. Okay. So here I got like this. This can be written like this, x less than 2 by 3. If I do like this, what I did, I done actually cross multiplication. But until unless if you don't know what is x, this is 100% wrong. You cannot cross multiply. This method is wrong. Do not cross multiply. Do not cross multiply in inequalities. You cannot cross multiply in inequalities. When you can cross multiply in inequalities, see, we can cross multiply when we know the sign of that variable, right? For example, you see here, we need to solve this inequality. Look here, we need to solve this inequality, 2 by x greater than 3. If you know that x is greater than 0, in the question only they mention that x is greater than 0. Greater than 0 means x is positive. Greater than 0, all numbers are positive. If you know all numbers are positive, you can solve this. How? I'll multiply. I am not cross multiplying. You try to understand. I'll multiply with x on both sides. Multiply with x on both sides. X into 2 by x greater than, here, 3 into x. Now you see what is x. X is positive. X is positive. As x is positive, you know that from rule number 2, for an inequality, if we multiply with same positive real number on both sides, sign of inequality remains same. That means greater than remains greater than only. I hope you are understanding. Right now, what happened? This x will get cancelled. What you will get? 2 is greater than 3x. Right now, I'll divide this inequality with 3. As 3 is positive real number, for an inequality, if I multiply or divide with a positive real number, inequality sign remains same. Here now this 3 will get cancelled. What you got here? You got that 2 by 3 greater than x. Look here, 2 by 3 greater than x. 2 by 3 greater than x can be written as x less than 2 by 3, right? So what you got here? You got that x is less than 2 by 3. Now you may question, sir, we got the same solution. No, sir, if you do like this, if I do like this, I got same thing. If you do like this also, you got the same solution. I got this solution because I know x is positive. If x is negative, then this is not the solution. You see here, we'll solve that also. This is the inequality we need to solve, and we know that x is negative. We know that x is negative. Okay, I want to find x from this inequality. Okay, right. For that, what I'll do, I'll multiply with x on both sides. Here what you know, x is negative. What you know here, x is negative. For an inequality, if I multiply with negative real number, sign of inequality changes. Rule number 3. Here greater than is there, no, that changes to less than. Okay, that changes to less than. Now this x will get cancelled. What you got? 2 is less than 3x. Now what I'll do, I'll divide with 3 on both sides. As 3 is a positive real number, for an inequality, if I divide with same real number, inequality sign remains same, less than remains less than only. So I'll divide this inequality with 3. Now see, what happens? This 3 will get cancelled. What you will get? 2 by 3, you see here, what you got here? 2 by 3 less than x. 2 by 3 less than x. It can be written as x greater than 2 by 3, right? So what you got here from this, you got that x is greater than 2 by 3. You observe the solution. You see, you observe these two solutions. When x is greater than 0, this is the solution of this inequality. If x is less than 0, see here, x greater than 2 by 3, here x less than 2 by 3. Solution difference is there. See, on the number line, somewhere if 2 by 3 is there, for this inequality, when we know x is greater than 0, x less than 2 by 3, x less than 2 by 3, this part is the solution, left hand side part. If this is the inequation, if you know x is less than 3, x greater than 2 by 3, this is the solution of this inequality. I hope you are understanding the difference. So in cross multiplying, don't cross multiply without knowing its sign, right? If you know the sign of that particular variable for an inequality, if I am multiplying with negative real number, if you are multiplying with positive real number, it's okay. Without knowing that whatever number you are multiplying, suppose x is greater than y is there, I'll multiply with some z. I'll multiply with some z. Xz is greater than y into z. This is wrong because you need to know z is positive or negative. Based on that, this inequality sign changes. Okay. Right. So I hope you understand these basic things related to inequalities. Now, based on these inequalities, we will solve 5 to 6 problems to get an idea of what are these inequalities, how to solve inequalities with the help of these rules. Okay. In today's class, what they are asking in these 12 questions, you observe, solve the inequalities for real x. Whatever we'll solve x values, they are the real x values. Okay, whatever x values we'll solve, they are all real x values. Okay, fifth question. What they are asking in this question? They are asking to solve this inequality for real x. You observe, I want to solve for x now. I want x values. To get x values, what I'll do, all x terms I'll write here general method. I said general method. 4x plus 3 is less than 5x plus 7. Actually, I am not going to do in this method. This is the first problem. Now you need to know actually what is the exact method. I want all x terms only. So for that, what I'll do, I'll subtract 3 on both sides. I'll subtract 3 on both sides just to get x terms only on the left hand side part. For an inequality, look here, 4x plus 3, subtract 3 on both sides, 5x plus 7 minus 3. This is the inequality. This is the inequality. For an inequality, if we subtract with same real number on both sides, sign of inequality remains same. That is rule number 1. This less than remains less than only. Now you can check here, plus 3 minus 3 will get cancelled. What you will get? 4x less than 5x. Look here, 7 minus 3. 7 minus 3 is 4. Okay, plus 4. Now what I'll do? Actually, I want all. I'm trying to solve x values now. I'm solving for x values here, right? So here, I need to write all x terms at one side. I need to write all x terms at one side. What is x here? X is a real value. So what I'll do, I'll subtract 5x to this on both sides. Listen carefully. Actually, this is not the method. I'm going to erase all these things. 5x plus 4 minus 5x. X is a real number. In the question only they said x is a real number. 5x is also real number. I am subtracting 5x. This is the inequality. For this inequality, I subtract 5x on both sides. Rule number 1 is what? For an inequality, if we subtract same real number on both sides, the sign of inequality remains same. That means this less than remains less than only. This is what rule number 1 is saying, right? Now you look right hand side part, this plus 5x minus 5x will get cancelled. Now left hand side part you observe 4x minus 5x, that is minus x less than 4. I got like this. Now this is the inequality now. I am trying for x now. I am looking for x value now. Here minus x is there in the left hand side part. What I will do, this inequality I will multiply with minus on both sides. This inequality I will multiply with minus 1 on both sides. If I multiply with minus 1 is negative real number now. Minus 1 is negative real number. For an inequality, if we multiply with negative real number, inequality sign changes. That is rule number 3. When you multiply with minus, what you will get? This is x, inequality sign changes. Less than changes to greater than. This is minus 4. Okay, so you got solution like this. But no need of writing all these steps. No need of writing all these steps. This is the actual method. If you want to use rule 1, rule 2, rule 3, this is the actual method. Listen, I'll just keep this aside. How you can do this problem very easily. Actual method is this only, but not necessary. In exam also, what method I am going to explain here, that you can follow. Right, this is the inequality. I need to solve this inequality. Very simple. You write all x terms at one side, remaining all terms other side. In this inequality, you write all x terms at one side, remaining all terms other side. Let me check here. Here, plus 5x is there now. You take plus 5x to the left hand side part. Then what you will get? You will get minus 5x, right? 4x minus 5x. What I am doing? I am writing all x terms at one side, 4x minus 5x. Here, less than symbol is there now. You keep it as it is. 3 is there now. Take it to the right hand side part. What you will get? 7 minus 3. You got this step. You look here, without doing this step, directly you are getting, directly you got this step actually. See, without doing all these things, directly you got this. Please try to understand what happened here actually. I taken 5x to this side means I subtracted 5x on both sides. That you need to keep in your mind. When you subtract a particular real number on both sides for an inequality, inequality sign remains same, less than remains less than only. I taken 3 to this side means for this inequality, I subtracted 3 on both sides. It can be understood easily. No need to do like this for every problem. This is the inequality. You write all x terms at one side, remaining all terms other side. Okay. You look here, 4x minus 5x, that is minus x, less than 7 minus 3 is 4. Right? Now, what I am trying for, I am solving this. That means I am looking for x values. To get x values in the left hand side part, I want x. To get x, I will multiply this inequality with minus 1. Multiply this inequality with minus 1. When we multiply this inequality with minus 1 is negative real number. When for an inequality, if we multiply with negative real number, inequality sign changes. This less than changes to greater than. Minus of minus x is x. X greater than. Minus 1 into 4 is minus 4. You see how simple you got this. No need of doing this procedure. Right? X greater than minus 4. Right? Now, what the question? What real values of x satisfies this inequality? You take any real x value which is greater than minus 4 that satisfies this inequality. Here, I will try to explain with the help of where is minus 4? Mark minus 4. Here minus 5 will be there. Here minus 4 is there. Here minus 4 is there. Okay. You remember, you mark minus 4 on the number line. Right hand side part of minus 4. All numbers are greater than minus 4. Right hand side part of minus 4. Whatever numbers are there, they are all greater than minus 4. Left hand side part of minus 4. What numbers are there? They are all less than minus 4. Here I want x values which are greater than minus 4 now. What are the x values which are greater than minus 4? You observe right hand side part. You can see this marked one. Can you see? Yes. This marked one. What is this? This is the solution. So if you want to write this in interval form, you need to write like this. Here, this is greater than. In the symbols, two types are there. This is greater than or equal to. When greater than or equal to given, we will write closed bracket. When strictly greater than is given, we will write open bracket. Strictly greater than or strictly less than. Okay. Here, this is strictly greater than. So, our answer will come in open interval form. Greater than minus 4 means you need to write this solution. From where to where? Minus 4 to infinity. Okay. Minus 4 to infinity. I hope you are all understanding. So these in this interval, whatever the real values are there, all those real values satisfies this inequality. This is the solution of this inequality. For example, in this interval 0 is there. In this interval 0 is there. Yes, 0 is there. So 0 is the solution of this inequality. It means when I substitute 0 in this, it satisfies. In place of x, you write 0. 4 into 0, 0. 0 plus 3, that is 3, less than 5 into 0, that is 0. 0 plus 7 is 7. Is 3 is less than 7? Yes, 3 is less than 7. So, whatever real x values you take in this interval, they are the solution of this inequality. I hope you are all understanding, right? So, I don't want to do this sixth question. This is similar, na? This question is similar to this fifth question, na? I want you to try this question. So, sixth question, you please try. I'll mark what is the answer for this. Answer is like this. X belongs to open interval minus infinity to minus 3 you will get for this problem. This is the answer for this problem, second problem, right? I want you pause this video, try this your own and make sure you will get this answer or not, right? Good. So 5, 6, 2 problems are over. Now we'll move to seventh problem. Seventh problem, eighth problem. You observe seventh problem, eighth problem, almost a similar type. Okay, I do one problem, you do other problem. Eighth problem you need to do. I'll write the answer after completion of the seventh problem. Okay, seventh problem. How to solve? What the point here? We need to solve this inequality. We need to find real x values which satisfies this inequality. Very simple. First, this left hand side part you simplify, right? Multiply with 3. What? I'll write the question. 3 into x minus 1 is less than or equal to 2 into x minus 3. This is the given question. Now what I'll do? I'll solve this left hand side part. Solve this left hand side part. Multiply 3x minus 3 less than or equal to. Now right hand side part you multiply 2 into x minus 3. What is that? That is 2x minus 6. Now further, how to do this problem? Actually, to get x values, first we'll add 3 on both sides. Afterwards, some number you will get. That number we'll subtract on both sides. We'll try to get x values. That's what I explained in the beginning. No need of doing all those things. In exam also, no need of doing all those things. Very simple. Here, you write all x terms at one side. You write all constants other side. Okay. Here, 3x minus 2x is less than or equal to. Here, minus 6 is there. You take minus 3 to the right hand side. That means that is plus 3. Actually, in this step, after this step, what happened? I taken 2x to this side means for this inequality, I subtracted 2x on both sides. When I subtract 2x on both sides, right hand side part 2x will get cancelled. Afterwards, and I taken minus 3 to this side means what? I added to this, I added 3 to this on both sides. For an inequality, if we add or subtract a real number on both sides, then inequality sign remains same. That's why less than remains less than only. I hope you are all understanding. You make sure that you are not multiplying with a negative real number. When you multiply with a negative real number, then only sign of inequality changes. Or else, if you multiply or divide with a positive real number, inequality sign remains same. If you add or subtract with same real number on both sides, then also inequality sign remains same. First 3 rules in first class we learned now. Okay, 3x minus 2x, that is x. X less than or equal to minus 6 plus 3. Minus 6 plus 3 is minus 3. So, x less than or equal to minus 3. You take any real x value which is less than or equal to minus 3 that satisfies this inequality. I'll take the number line to just identify the solution. Here minus 3 is there. Na? You mark it. Where is minus 3 on the number line? You can look here. Here is the minus 3. Greater than or equal to is there. Left hand side part of minus 3. Left hand side part of minus 3. Whatever numbers are there, they are all less than minus 3. Right hand side part of minus 3. Whatever numbers are there, they are all greater than minus 3. Keep this in your mind. Here I want less than or equal to minus 3 means left hand side part numbers I want. Left hand side part means here minus infinity will be there. So x belongs to, what to write here? X belongs to, for infinity always open bracket because infinity is not defined. Infinity is not defined. What is the answer? X less than or equal to minus 3 means? Actually you can stop here, but I am writing this in interval form. Minus infinity to 3. Minus infinity to 3. For this 3 closed bracket or open bracket. Here less than or equal to is there. Na? Less than or equal to is there. Na? That means when less than or equal to is there, we will write closed bracket. When strictly less than is there, at the time we will write open bracket. Okay, here less than or equal to is there. That's why this is closed bracket. So for seventh problem, answer is minus infinity to closed 3. You take any real x value in this interval, substitute in this inequality, definitely it satisfies. For example, in this 1 is there. In place of x, you put 1 in this. In place of x you put 1. Left hand side part will become 0, less than or equal to 2 into, in place of x you put 1. 1 minus 3. 1 minus 3 is what? Minus 2. What happened here? Minus 3, minus 3, minus 3, minus 3. Look here, look here. Here, less than or equal to minus 3 is there, na? Less than or equal to minus 3. Which question I am doing? 7th question. 7th question. X less than or equal to minus 3. Correct. Minus 3. X less than or equal to minus 3. Right. You can see here what happened in this. In this 1 is not there. That's why that is not satisfying this inequality. It's good that we are checking. Right. In this, you take any real x value in this interval, substitute in this, it definitely satisfies. Here x less than or equal to minus 3 we got now. Right. In this, what number is there? Minus 4 is there. You can observe here all numbers less than or equal to minus 3. In this, minus 4 is there. Substitute minus 4 in this, definitely satisfies. 3 into minus 4 minus 1, that is minus 5, less than or equal to 2 into, in place of x what I am writing? In place of x I am writing minus 4 na? Minus 4 minus 3, that is minus 7. Okay. So minus 15 is less than or equal to minus 17. Right. So I hope you are all understanding. In this interval, you take any real x value, substitute in this, definitely it satisfies. Similarly, I want you to try this 8th problem your own. For this 8th problem, answer is like this. Open interval minus infinity to closed 4. This is closed 4 because in this question greater than or equal to is there. Na? This is the answer you will get when you solve this 8th question. Okay. Now, we'll move to next set of questions. 9th question, 10th question. I'll do 9th question. You try 10th question, your own. Both are same type, na? Okay. So, how to solve this 9th question? First thing, what they given? X plus, x by 2 plus, x by 3 is less than 11. Generally, what we'll do? We'll try to write all x terms at one side, remaining all other side. Right? So, here already all x terms are at one side only. You just simplify this. Okay, just simplify. What is the LCM you will get? 6 is the LCM. Okay, what you will get in the numerator? 6x. Here by 1 will be there. X divided by 1 will be there. 6x plus, you all know these things, how to write. 2 in 6 3 times 3x. 3 in 6 2 times 2x less than or equal to 11. Strictly less than. In the question, strictly less than given. Okay, you observe 6 plus 3 9. 9 plus 2 11. 11x divided by 6 less than 11. Okay. Now, you multiply both sides with the 6. You multiply. What I want? I want x values. I do one thing. I'll multiply with the 6 by 11 on both sides. Listen. What I want? I want x values. That means in the left hand side part, I want x only. To get x only in the left hand side part, for this inequality, I'll multiply with 6 by 11. Look here. If I multiply with 6 by 11, 6, 6. 11, 11 will get cancelled, so that I'll get x only. I hope you are understanding. This is the inequality now. For this inequality, I'll multiply with 6 by 11 on both sides. 6 by 11 is positive or not? Yes, 6 by 11 is clearly positive. For an inequality, if we multiply with positive real number, inequality sign changes or remains same? Rule number 2. For an inequality, if I multiply with a positive real number, inequality sign remains same. So, multiply with 6 by 11 on both sides. 6 by 11 into 11x by 6 less than 11 into 6 by 11. This is the inequality now. For this inequality, I multiplied with 6 by 11 on both sides. As 6 by 11 is positive, when we multiply with a positive real number, inequality sign remains same. Less than remains less than only. Now look here, this 6 6 will get cancelled. 11 11 also will get cancelled. This 11 11 also will get cancelled. What you will get? You will get that x is less than 6. In the question, they given strictly less than. Here strictly less than is there. X is less than 6 I got. So, answer. If you want to write the answer, how you will write? Less than 6. On the number line, you mark 6. Left hand side part of 6, all numbers are less than 6. Right hand side part of 6, all numbers are greater than 6. No need of every time writing number line. Here I can write directly answer. X belongs to open interval minus infinity to 6. I hope you are all understanding. If you are understanding these problems, please drop a like for these videos. Okay. Now, I want you to try this 10th problem your own. See, mathematics you can enjoy not by listening. When listen first to learn. Afterwards, you take some problems and you try your own. When you try the problems your own, then only you can enjoy this mathematics. Mathematics is such a subject. If you are getting answers for every problem, complete night you can study without boring. But for the first problem only, in case if you felt bored, then we won't get interest to study mathematics further, right? So what I am trying to say, you can first learn this ninth problem. You learned this type of problems how to do. Then to get perfection, you must try one problem of your own. Okay, 10th question answer is what they given. 10th question answer is minus infinity to minus 6. This is the answer. X belongs to, you take any interval, any real value in this interval, that definitely satisfies this inequality. Okay, right. Now we'll move to next question. Right, 11th question, 12th question. Okay, 11th question, if you observe, first what I'll do in this 11th question, what I need to find, I need to solve this inequality. What real values of x satisfies this inequality? I'll simplify this left hand side part, and then I'll simplify with this right hand side part. Let me start. Right, solution. 3 times of x minus 2 divided by 5 less than or equal to 5 times of 2 minus x divided by 3. First simplify this left hand side part. Simplification means numerator multiply with 3 into x minus 2. What is that 3 into x minus 2? That is 3x minus 6 divided by 5 less than or equal to, here multiply with 5 into 2, 10 minus 5x divided by 3. Actually, in inequalities, we cannot cross multiply. But when you are clear with the properties, you can cross multiply. Here you see this 3, 5 we can cross multiply because these two real numbers are positive numbers. These two are positive real numbers. When both the numbers are positive real numbers, we can cross multiply. We can cross multiply because for an inequality, if we multiply with positive real number, inequality sign remains the same. I hope you are understanding. Okay, we can cross multiply here. Actual point is, first I need to multiply with 5 on both sides. Next, I need to multiply with 3 on both sides. Like that we need to do. Not necessary, you just cross multiply, but make sure that there is these two are positive real numbers. Okay, positive real numbers. Now you can cross multiply. What you will get? 3 into 3x, that is 9x minus 6 3s are 18 less than or equal to 50 minus 25x. Okay, now somehow I got little simplest form. I need to solve this. To solve this, what I'll do? I'll write all x terms at one side, remaining all terms other side. Here minus 25x is there. You take it to the left hand side part. Ajay Dharmpuri, good morning sir. Good morning Ajay. You take minus 25x to the left hand side part. What you will get? 9x plus 25x. I'll write here 9x plus 25x less than or equal to. You take minus 18 to the right hand side part. Then what it will become? 50 plus 18. Right? 50 plus 18 is what? That is 68. So here this is 34. Right? 34x. 9x plus 25x is 34x is less than or equal to 68. Okay, now what I am trying for, I am solving for x values. I am looking for what real x value satisfies this condition. Now you observe, I got this one. I want x. In left hand side part, I want only x. So to get only x here, this is the inequality. Now for this inequality, you divide with 34 on both sides. You divide with 34 on both sides. 34 is positive real number. For an inequality, if you divide with positive real number, inequality sign remains same or changes. For an inequality, if you multiply or divide with a positive real number, inequality sign remains same. That means here less than or equal to is there. Now this less than or equal to remains less than or equal to only. Here this 34 will get cancelled. 34 in this 68 2 times. Correct? Yes, 2 times. So what you will get? X less than or equal to 2. X less than or equal to 2. You take any real x value which is less than or equal to 2, that definitely satisfies this inequality. So for example, you just mark 2 on the number line. Left hand side part of 2, all numbers are less than 2. Right hand side part of 2, all numbers are greater than 2. I hope you are understanding. So if you want to write this in interval form, how to write? X belongs to minus infinity to, for infinity, always open bracket. Whenever infinity will be there, always open bracket. Good. What are you using to write the screen? I am also trying YouTube channel. At the end of the class, I'll discuss. Total 16 problems are there. After completion of 16 problems, I'll discuss, Ajay. Right? If you want, you can stay. Right? Now it may create some disturbance in the class. Okay, minus infinity. I'll explain. I'll tell you what software I'm using. It's not big secret. Less than or equal to is there. Equality is there. So I need to keep closed bracket. Minus infinity to 2. Okay. Good. Chirag Kumar, same. Very good, Chirag. I hope you are following these things. Good. So these, you take any real x value in this interval, that is going to satisfy this inequality. Okay. So I want you to try this problem. Very simple. First, you simplify left hand side part. You multiply with 1 by 2. Then what this will become? This will become 3x divided by 10 plus 4 by 2 is 2, greater than or equal to 1 by 3 into x is x by 3 minus 6 by 3 is 2. You will get like this. Afterwards, you write all x terms at one side, remaining all other side. Okay. And then you will get x values. For this problem, this is 12th problem. Na answer you must get. This is homework. I want you to do this problem your own. For this answer is minus infinity to open interval minus infinity to closed interval 120. This is the answer. Okay. Right. Now this 13th problem, 14th problem, both are similar type. You can observe 13th, 14th, both are similar type. Any 13th problem I'll do. I want you to do the 14th problem. Okay. 13th problem, what they given? 2 into 2x plus 3 minus 10 is less than 6 times of x minus 2. What we want? We want to find x values which satisfies the inequality. What real values of x satisfies this inequality? First, I'll simplify this left hand side part, simplify, and then simplify right hand side part also. Simplify, what you will get? 4x, 2 into 2x is 4x plus 2 into 3 is 6 minus 10 is less than what you will get? 6x minus 12. Okay, now you can observe here little bit simplification also possible. 4x, this is 6 minus 10 is minus 4 less than 6x minus 12. Now what I'll do? I'll write all x terms at one side, remaining all other side. Okay. So 4x minus 6x less than minus 12 plus 4. 4x minus 6x is what? That is minus 2x less than minus 12 plus 4. Minus 12 plus 4 is minus 8. Okay. Good. Now what I am trying for? I am trying for x values. Here left hand side part minus 2x is there. But I want only x. How I can get only x? For this inequality, I'll divide with minus 2 on both sides. For an inequality, if I divide with a negative real number, what happened? Rule number 3, inequality sign changes. Less than changes to greater than. Okay. So minus 2x divided by minus 2 minus 8 divided by minus 2. This is the inequality. Na? I divided with minus 2 on both sides. Then inequality sign changes. This less than is there. Na? Less than changes to greater than. Okay, this minus 2 will get cancelled. This minus also will get cancelled. What you will get? You will get that x is greater than 4. That means right hand side part of number 4. All are greater than 4. Left hand side part of number 4 on the number line. All are less than 4. Here I want x values which are greater than 4. So what is the solution I'll write? I'll write x belongs to open interval 4 to infinity. I hope you are all understanding. And in same way, you please simplify this one. You just simplify this one like this is a minus 3x 37 minus 5, that is 32 less than greater than or equal to 9x minus multiply with 8x plus 24. And just you write all x terms one side like that you do, you will get the answer. I want you to try this 14th question your own. Okay. For 14th question, answer is open interval minus infinity to closed 2. Okay. I hope you are all understanding. If you like these videos, please drop a like. Okay. Right. Next, we completed 14 problems. Very good. Good. Now you see this 15th problem. I said in this class we are going to do up to question number 16. Only these two questions are pending. I'll do both the questions. 15th question, 16th question, both I'll explain. Okay. 15th question solution. Okay. What they given? X by 4 less than 5x minus 2 divided by 3 minus 7x minus 3 divided by 5. So much of sweating. Okay. Okay, alright. So here x by 4, how to solve this inequality? How to solve this inequality? We need to find real x values which satisfies this inequality. First, what I'll do, this right hand side part, what is there? I'll simplify this. I'll simplify, right? This is normal simplification only. Okay, those who complete SLC, they can do it very easily. X by 4 less than, what is LCM? 3, 5 LCM, 15, right? Now what you will get? 3 in this 15 5 times. So what you will get? 5 into 5x minus 2. 5 into 5 into 5x minus 2. Okay. Minus 3 into 7x minus 3. I'm just trying to simplify this right hand side part. X by 4 is less than, this is 25x minus 10 minus 21x plus 9 divided by 15. Okay. X by 4 is less than, you look here, 25x minus 21x, that is what? That is 4x. 4x minus 10 plus 9, that is minus 1 divided by 15. Okay. Now, actually what I am trying for? I am trying for x values. You can observe here in linear inequalities, we cannot cross multiply actually, but in the denominator, both the numbers are positive real numbers, we can do multiply, cross multiply here, as these two are positive real numbers, you can cross multiply. What you will get? 15x is less than 16x minus 4. Okay. What you are looking for? You are looking for x. That means you want all x values at one side. So you write all x values at one side. What you will get? 15x minus 16x is less than minus 4. Okay. 15x minus 16x, that is minus x, is less than minus 4. Okay. What I am looking for? I am looking for x values. I am looking for x values. That means I want x in the left hand side part. To get x in the left hand side part, you multiply this inequality both sides with minus 1. Multiply this inequality with minus 1 because I am looking for x values now. Minus 1 is the negative real number. For an inequality, if we multiply with negative real number, sign of inequality changes. Sign of inequality changes, right? Multiply with minus 1 into x, that is plus x. As we are multiplying with negative real number, inequality sign changes. That means this less than is there, now less than changes to greater than. That is what we learn in rule number 3, right? Greater than, minus 1 into 4 is 4. So x greater than 4. You take any real x value which is greater than 4 that satisfies this inequality. So here, what is the answer for this? X belongs to x greater than 4 means on the number line right hand side part of 4, all numbers are greater than 4. Okay. So 4 to infinity, you take any real x value in this interval, that satisfies this inequality. Right? I hope you are all understanding. Good. Now, question number 16. Okay, question number. Right. This is the last question in today's class. Question number 16. Okay. Right. I need to solve this inequality. I need to find real x values which satisfies this inequality. Okay. First thing, I'll write the question. What they given? 2x minus 1 divided by 3 is greater than or equal to 3x minus 2 divided by 4 minus 2 minus x divided by 5. Just written given inequality. To solve this inequality, first I'll simplify this right hand side part. Okay. Right. Good. So 2x minus 1 divided by 3 is greater than or equal to, how to simplify? LCM, right? 4 5s are, right? 4 5s are 20. Okay. And now this 4 in this 25 times, right? What you will get? 5 into 3x minus 2. Okay. Minus 5 in this 24 times. Okay. So 4 into Rajiv Kumar, good morning, minus 4 into 2 minus x. Okay, right. So here again further I'll try to simplify this part. Okay, 2x minus 1 divided by 3 is greater than or equal to, you just simplify this part, what you will get, 15x minus 10 minus 8 plus 4x divided by 20. You can observe in linear inequalities generally we cannot cross multiply, but in the denominator if both the numbers are positive then you can cross multiply. Okay, just cross multiply here, what you will get, 20, that is 40x minus 20. What happened? 20 into 2x minus 1, that is 40x minus 20. Okay, and here simplification is there. Now little bit I'll simplify. Listen, 2x minus 1 divided by 3 is greater than or equal to, look here, 15x plus 4x, that is 19x. 19x minus 18 divided by 20. Okay. Yes, Shiva, good morning. Good morning. Right. Now, here this is positive real number, this is positive real number. When these two are positive real numbers, you can cross multiply. Okay. Cross multiply, what you will get? 20 into 2x minus 1 is greater than or equal to 3 into 19x minus 18. Now, you simplify this left hand side part, what you will get? 40x minus 20 is greater than or equal to 3 into 19, that is 57x minus 3 into 18, that is 54. Okay. Now you observe here I got somehow simplest form now. Now to solve this further, Sudeep Durai, good morning. Good morning to all. We are at the end of today's class. We are doing 16th problem. Right. Now to simplify this further, what I'll do, I'll write all x terms at one side. Right. All x terms at one side. That means 40x minus 57x greater than or equal to minus 54 plus 20. Okay. 40x minus 57x, this is minus 17x. Minus 17x is greater than or equal to minus 54 plus 20, that is minus 30. Minus 34. Minus 34. Okay. Now what I want actually? I want x values now. I want x values. To get x values, you divide both sides with minus 17. To get x values, you divide with minus 17 on both sides. Minus 17 is the negative real number na? For an inequality. If we divide with a negative real number, inequality sign changes. This greater than or equal to changes to less than or equal to. So here minus 17x divided by minus 17. Greater than or equal to changes to less than or equal to. Why? Because for this inequality, I am dividing with negative real number. For an inequality, if I divide with a negative real number, inequality sign changes. Now look here, this minus 17 will get cancelled. And this minus 17 in this 34 2 times, right? What you will get here? You will get that x is less than or equal to 2. So how to write this in interval form? You know that on the number line, left hand side part of 2, all numbers are less than 2. So x belongs to open interval minus infinity 2. Here less than or equal to is there. When less than or equal to is there, at that time 2 is included. For infinity, always open brackets. So this is solution for this inequality. Whatever real x value you take which are less than or equal to 2, that real value satisfies this inequality.